All right. Hi, everyone. Welcome to my next video. We are discussing how to draw the trigonometric function. We already discussed what is the effect of change on amplitude on trigonometric function. Today, I will show you what is the effect on the graph if period of the function is changed. All right. Let's take our original graph, y equal to sine x. That is our basic graph. And we already drew graph for this function in last video. So which goes like that. Cos that's 0, that's 180 degree, and that's 360 degree, and that's 90 degree there. Okay. Which is pi over 2, and that's pi, and that is 3 pi over 2, and that's 2 pi. And we know that's 1 and that's minus 1. We already explained how we get that graph. Okay. Now the question is how to draw the graph if period of the function is changed. So I already explained what is the meaning of period. I'm going to tell you again what is period means. So if you see this graph, we started at 0 and then up to 2 pi, which is 360. After 360, it is going up again. So means it is going to follow the same pattern as if we start from the 0 and it is going up again from 0 towards 1, right? So same thing is going to be happen after 360 degrees. So means our graph is going to be repeat exactly after 360 degrees. So that's why period of this graph y equal to sine x is 360 degree. All right. That's how we can find a period of any function from the graph. The graph is going to be repeat itself again as it is starts from 0. Okay. So period of this function is 2 pi. Let us take another equation when your y is equal to sine of 2x. Just double the angle. So let's see how to find the period of this function when your graph is y equal to sine 2x. All right. So when your graph is y equal to sine 2x, what is our general equation? General equation is y equal to a sine b in bracket x minus a. This is our general equation. And what is the value of b if you compare these two equations? Value of b would be 2. But what is the formula to find period of sine and cosine both? It is also always equal to 2 pi over b because 2 pi is a period of a basic function. All right, so 2 pi, what is the value of b for our given equation? 2, we got it. So it's equal to pi. So what does it mean? It means period of this function y equal to sine 2x is pi, means it is going to be repeat exactly after 180 degree, like it is repeating after 360 degree. But if it is sine 2x, it is going to be repeat after 180 degree. That's how you can find period of any trigonometric, basically sine and cosine from this formula. I will show you how that happened here. Let's see if that is actually going to happen by comparing it with the graph of that function. So suppose we have y equal to sine 2x. Let's make a table for that graph. And then we will see what would be the graph of sine equal to 2x look like. Let's see here. So that's x and that's y. Suppose x value is 0. Let me take value of 45. Let's take the 90, 135, and then 135. I'm just adding 45 in everyone. So 135 and then 180, of course. Just give me a second. Where is that thing? Yeah, right there. 180. And then I think we can take one more value, 180. then it would be 225. All right, let's take these values of x and let's see what would be the graph of this function look like. I'm going to mark that here. Just ignore my line is not horizontal. That should be a horizontal actually, but that's fine. So 0, that would be 45. Let's suppose that would be 90 then. That would be 135 then. And that would be 180 then. And that would be 225 then. Okay, let's put it there. So when x is 0, it means sine 2 times 0 is sine 0, right? So sine 0 is 0. Awesome. So when sine is 2 and x is 45, so sine 2 times 45, so basically sine 90, and sine 90 is 1, right? Yes, it is. And then you put when x is 90 there, so when x is 90, so sine 180, sine 180 is 0, right? And when you put x equal to 135 there, so that would be sine 2 times 135, so your value would be minus 1 when x is 135. When x is 180, it is 0 again. And when your x is 225, your sine would be 1 again. All right, let's mark the values. When x is 0 degree, all these are in degree, of course. So y is 0 right there. So when x is 45, y is 1. We can suppose that is our 1. All right. And when x is 90, y is 0, of course. And when x is 135, it is minus 1. We can suppose minus 1 is there. So that will be there then. Okay. Now when x is 180, it's 0 again. And when x is 225, it is 1 again, right? So let's mark the graph. Going there. Oops. Very bad at drawing, but you know. And then there, and then there. All right. So if you see this graph, no, it's a graph of sine 2x. So if you see, we started at 0, and then we go up, and then exactly after 180, again we are going up, right? So if you see from the graph, it is very much clear. Exactly after 180 degree, our graph is going to repeat itself, right? It is going up there, so it is also going up after 180. So it means period of this function is 180, which we already proved from our period formula. 180 degree, pi means 180. Awesome. Yeah, so that's how you can find period of any function if equation is given to you, and then you can also draw the graph. And if graph is given to you, you can just see the graph and see at what angle and after what angle is going to be repeated. So suppose take another example. If you have a y equal to sine 4x, right? Then what is the period of this graph? You know what is the equation of period? P equal to 2 pi over b. We will compare this graph with general equation y equal to a sine p x minus c. So it means our b is 4, so period is 2 pi over 4, right? Which means period is pi over 2. So it means this function is going to be repeat itself after 90 degree angle. Makes sense? Thanks for watching. So by this way, if period is changing, you can draw the graph of any function. And you can also find the period by comparing it with the general equation. In next video, I will come up with what is the effect on the graph if phase is going to be changed. Thank you very much for watching. Have a wonderful day. Thank you. Bye.